So for number 26, the diagram below, triangle LMO is isosceles with LOs equal to MO. So these two are the same. If the measure of angle L is 55 degrees and the measure of angle NOM is 28 degrees, what is the measure of angle N? So we need to find the measure of this one. So it's going to be like a scavenger hunt. First, I'm gonna find the measure of this angle here. Since we have an isosceles triangle, then these two angles are also congruent. So this is 55. And then we have a linear pair here. So this is 55. This angle on the inside of the other triangle is going to be 180 minus 55, which is 125. And now to find the third angle inside this triangle, I could use the triangle sum theorem. So it would be 180 minus 125 minus 28. That's going to give me the measure of angle N. So 180 minus 125 minus 28, 27. Okay. Next one, number 27. In the diagram below, triangle ABC is similar. So that symbol there means similar to triangle RST. Yes. All right, go for it. All right. Yeah, good job. Yep. Good job. It is 3. Any questions for that one? Okay, moving along. Does someone have number 28? All right, go for it. So 7x is equal to 5x plus 30. All right, good job. Number 29. As shown in the diagram below, AC bisects angle BAD. So this angle right here is, so that means that you create two congruent angles if you bisect it. And angle B is congruent to angle D. Which of the following could be used to prove that triangle ABC is congruent to triangle ADC? Okay, so we have two angles, and the triangles also share this side here in the middle, CA. So we have angle, angle, side, which is option 4. By the way, I'm recording the explanation, so you'll have access to that on Google Classroom. 30. A packing carton in the shape of a triangular prism is shown in the diagram below. What is the volume in cubic inches of this carton? So to find the volume of this prism here, you need to find the area of this front part, which is a triangle, and then multiply by this length. So the area of a triangle is 1/2 times base times height, and then you're going to multiply by the length of it. The base is 6, the height is 4, and then the length is 10. So 1/2 of 6 is 3, 3 times 4 is 12, and 12 times 10 is 120. Okay, for 31, as shown in the diagram below, a landscaper uses a cylindrical lawn roller on a lawn. Man, that's really old school. The roller has a radius of 9 inches and a width of 42 inches. So the nearest square inch, the area the roller covers in one complete rotation is. Okay, so this question is asking, if you do one complete rotation, what is the area of that? So you're looking for the surface area of the cylinder, but the surface area includes these end caps, this circle on the front and then the circle on the back. Those don't actually touch the ground. So you're gonna omit that from the calculation. So let me show you what I mean by that. So first, this write the area. Hold on, someone's trying to. Let me make sure these people are able to come in. Okay, so the surface area of a cylinder is 2 pi r h plus 2 pi r squared. This part is I'll call it the tube or the shaft of that cylinder, and this part is the end caps. For this particular problem, we do not include the end caps. So therefore the area for this one, we're only going to use this front part. So 2 pi, the radius is 9, and then the height is 42. So 2 times pi times 9 times 42, 2375.0. So it's going to be option 2. Okay, 32. What are the coordinates of A Prime the image of -3, -4 after a rotation of 180 degrees about the origin. So just a reminder, if you are rotating 180 degrees, you do the opposite of each one of those coordinates. So if A is -3, 4, A prime becomes +3, -4. So the opposites. For 33, in a right triangle, the length of one leg is 9, the length of the other leg is 6. What is the length of the hypotenuse? So you could use the Pythagorean theorem. A squared plus b squared is equal to c squared. And you're given both legs. Sounds pretty straightforward. So this turns into 81 plus 36. And the sum of that is 117. And to get c by itself, you find the square root of both sides. Oh, you simplify 117? So yeah, it's multiple choice. So you could have the simplified version or not. Okay. Or if it was check all that apply, then it could have both. Okay, 34. And the diagram below of circle O, the chords A, B, and CD intersect at E. If the measure of angle AEC is 34 and the measure of arc AC is 50, what is the measure of arc DB? So we're looking for this arc over here. Okay, so when you have two chords that intersect, then this middle angle right here, these vertical angles, is actually half of the sum of the two intersecting arcs. Okay, so the vertical angles is half of the sum of the arcs. Okay, so now that I set up the equation, you can solve for x. The opposite of 1/2 is multiplying by 2. So it turns this into 68. It's equal to 50 plus x. And then subtract 50 on both sides. X is 18. For 35, in the diagram below of circle O, PAC and PBD are secants. If CD is 70, so this arc here is 70, and arc AB is 20, what is the degree measure of angle P? So now we're looking for this angle here. So when you have secants, the angle is half of the difference of the arcs. So the angle is half of the difference of arcs. So the angle, so this angle P, that's the angle that we're looking for, is half of the difference, 70 minus 20. So half of 50 is 25. $36. And the diagram of the circle O below, chords A, B, and C, D are parallel. Okay, so I have these arrows here. BD is the diameter of the circle. Okay. If AD is equal to 60, what is CDB? See, so we're looking for this angle right here. Okay. So one thing to remember is that an inscribed angle is half of the arc. So angle ABD, it's an inscribed angle. So it'll be half of 60. So this angle is 30. And since we have parallel lines, this angle and this angle are congruent because they are alternate interior angles. So angle CDB is also 30 degrees. So 2 steps for that one. For 37, in the diagram below, triangle AG and triangle OLD, GAE is congruent to LOD, and then AE is congruent to OD. To prove that the triangles are congruent by SAS, what information is needed? Okay, so we have side and angle. So we need another side. So we need to show that this side is congruent to this side. That's going to be AG congruent to OL. We need 38. All right, go for it. All right, that worked. Okay, good job. Number 39. When a button is pressed, a computer program outputs a random even number greater than 0 and less than 10. What is the probability that you press the button and the program outputs a number less than 5? All right, so first the sample space. Like Sophia described how many were in total. In this problem, we're going to figure out how many numbers, what are all the different numbers you could get. So greater than 0 or less than 10. And it has to be an even number. So all the even numbers greater than 0 and less than 10 are 2, 4, 6, and 8. Does not include 10 because it has to be less than 10. Okay. So our sample space has 4 items. And then what is the probability that you press a button and the program outputs a number that is less than 5? So out of your sample space, which are less than 5? These two right here. So the probability is 2/4, which simplifies to 1/2. Okay. Next one. Which expression represents the volume and cubic centimeters of the cylinder? So volume is um, pi r squared times the height. So for this problem, it's going to be pi times, you have the diameter, so the radius is half of that. 6 squared times the height, 27. And then looking at the answer choices, you don't have to multiply by pi, you're just going to write it next to it. So 6 squared times 27, 972. So the answer is the third option. 41. And the diagram below, a right circular cone has a diameter of 8 inches and a height of 12 inches. We're going to find the volume of this cone. So the volume to find the cone is similar to the cylinder, but the height you need to divide it by 3. Once again, you're given the diameter, so make sure you find the radius by dividing by 2. Height is 12 over 3. And 16 times 4 is 64. And then we actually need to multiply that out. So 64 pi, 201.06. So that'll be the first option. Okay, 42. Find the value of x. So I'm going to simplify this. So we have a diameter here. So all of this here should add up to, those arcs should add up to 180. So I'm going to set up an equation, x plus 64 plus 65 plus 60 is equal to 180, because that makes a semicircle. So x plus 189 is 180. So therefore x is -9. Okay. 43. Again, I'm gonna use that trick with the semicircle. Okay, so this is 72. This arc over here would be 180 minus 72, which is 108. And then we could see that this angle here, it's an inscribed angle. So an inscribed angle is half of the intercepting arc. So 108, half of that, so divided by 2, is equal to the inscribed angle. So 54 is 8x plus 6. Subtract 6. So 48 is 8x. So therefore x is 6. moving along. Page 44. From the information in the diagram, can you prove that triangle FDG is congruent to FDB? Well, I see angle, 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 but that does not prove congruence. It proves similarity, but not congruence. But we could see that both triangles include DF. So that's a side. So you could go with angle, side, angle. For number 45, state whether triangle ABC, so this triangle here, and AED are congruent. Okay, so looking at the tick marks and the angles, we have angle, side, side, and remember, angle side does not prove congruence. I had a poster in my classroom, remember? So no, there's not enough information. So we continue over here. Sorry, it's kind of lagging on me. There you go. Okay. Given ABC is congruent to PQR, angle B is equal to 3B plus 4, and Q is equal to 8B minus 6. Find the measure of B and Q. So without drawing this out, since B and Q are the letters in the middle, then they correspond to each other. So we could actually set these expressions equal to each other. You solve for B, subtract 3B on both sides, add 6 to both sides, and then divide both sides by 5. So I know V is 2, and then we're gonna find the measures of the angles. So 3 times 2 plus 4, 6 plus 4 is 10, and then just to be sure, I'll plug it into the other one. 8 times 2 is 16, minus 6 is also 10. Alrighty, 47. I need to solve for x. Sorry, the instructions got cut off. Okay, so I know that there are 360 degrees in a circle. I also know that an inscribed angle is half of the arc, so this has to be 66. So I could set up an equation now. I'm going to add these three up, and it should add up to 360. So let's see. 135 plus 66 minus 9. It's 192. So 12x plus 192 is 360. And then 360 minus 192 is 168. And if you divide that by 12, you get 14. What else must you know to prove that the triangles are congruent by ASA or by SAS? All right, so we have pair of angles that are the same, and then they share this part. So we have side. So for this first part, we have AS. So to get the other A, we need to show that these two angles are congruent. And those angles are ACD and CAB. So it's going to be one of these two here. And then to show SAS, so we need another side. So we're going to need this side up here. I'm sorry. Let me erase the green. So we have angle and side. For SAS, we're going to need this side over here to get SAS. So AD and BC, which is this one. So the answer is B. For 49, name the theorem or postulate that lets you immediately conclude that triangle ABD is congruent to CBD. Yeah, go for it. Nice. Side angle side. Alrighty. Good job. Okay. 50. For 50 and 51, you need to name the transformation. So our pre-image is the one without the tick marks. So how do you go from this purple image to the other one? So if you reflect across two, it's not a reflection. It looks more like a rotation. Counterclockwise is this way, and then clockwise would be this way. So it's not going to be C, so it's going to be B. Reflection across Y equals X. Hold on, this thing is kind of slow right now. There it is. Give me 1 minute. Okay, I restarted it. Hopefully it speeds up. Okay. Okay, so that's the line y equals x, and if you reflect across that line, it's not going to match up with that one. So that's why it's b. Okay. 51. This is our pre-image, the one without the tick marks. Okay, so how do you go from here to here? Okay, so you go to the left 2 units and up 2 units. So that's the translation. And if you go to the left, that's negative. And if you go up, that's positive. So negative 2, 2. Alrighty, 52. We have alternate interior angles. So you could set those equal to each other. So if 7x is 63, x is 9. For 53, these two angles are supplementary. So the equation is going to be 15x plus 6x plus 12 is 180. So 21x is equal to 168. If you divide that, you get 8. Okay. 54. Consider the right triangle shown below. Which trig ratios are equivalent to 5/3? Select all that apply. Alrighty, so trig ratio, SOHCAHTOA. The cosine of A adjacent. The adjacent of A would be 10. And the hypotenuse is 26. And that simplifies to 5/13. So A is correct. We need to select all the apply, so we need to check them all. The sine of A, so we start the same angle. The sine is opposite, which is 24 over the hypotenuse, 26. That does not simplify to 5/3. Okay, so not that one. The tangent of A is opposite over adjacent. So 24 over 10. And that doesn't simplify to 5/13. Cosine of C. So now we're jumping over to this angle over here. Cosine is adjacent, which is 24 in this case, over the hypotenuse. No, that does not simplify. The sine is opposite over hypotenuse. So that's going to be 10 over 26. So that one does simplify to 5/13. And then the tangent of C would be opposite 10 over adjacent 24. And that wouldn't work. So A and E are the correct answers. 55. In the figure shown below, the measure of angle C is 40 and AB is 8. Which equation would be used to find X? So we have this angle. The 8 is opposite. The hypotenuse is adjacent. So the trig ratio that uses opposite and adjacent is tangent. So the tangent of 40 degrees is 8 over x. Okay. And if I solve for x, you get, first you cross multiply. So this was over 1. If you cross multiply, you get that. And then if you divide both sides by the tangent of 40, you get 8 over the tangent of 40. Okay. That's none of these answers. So what they did here, if this is 40 degrees, this one up here has to be 50 degrees. So if I'm using angle A now, x would be the opposite and 8 would be the adjacent. Still tangent, but now it's the tangent of 50. X over 8. And if we cross multiply, x is 8, 10, 50. The answer is C. That's a tricky one. Okay, moving along. 56. Find the measure of the indicated angle to the nearest degree. Alrighty. So this is opposite and this is hypotenuse. So it's going to be sine. So the sine of, I'm just going to call this x. The sine of x is 14 over 39. And to solve for x, you do the inverse. This is when you're solving for the angle. So the inverse of 14 over 39. Definitely need a calculator for this. So inverse of 14 over 39. All right, this thing kind of froze on me. Hold on. Okay. All right. So I got a decimal. Notice it's not one of the answer choices. We're looking for the measure of the angle in degrees. So make sure your calculator is in degree mode. So that's the mistake that I made. So make sure it's in degree mode. I'm gonna try it again. So it'll be the inverse of the sine. Okay, the calculator says arc sine. They mean the same thing. As long as you click the button correctly, you should be fine. And it was 14 over 39. Yes. And it's approximately 21. The answer is C. Okay. 57. Same thing. Let's say this is X. Yeah, go for it. All right, good job. Okay, that's 57. And a few more. 58. The equation x equals 11 over sine of 42 correctly determines the length of x for which of the following right triangles. So if we're using sine, then you need opposite and hypotenuse. Okay, A doesn't have the hypotenuse. B, it does. Opposite and hypotenuse. C, no, the 11 is the adjacent, so it's not C. And then D also has opposite and hypotenuse. Okay, so now we have to figure out which one is the correct one. So for here, if you want sine of 42, it would be 11 over x. And if you cross multiply, you get x sine of 42 is equal to 11. And then for this one, you're going to have to divide sine of 42 on both sides. So this one actually matches what we need here. So it's B. 60 simplified. So 4 divides 28. Square root of 4 is 2. So 20 square root of 7. Done a few of those already. 61. Find the coordinates of the vertices of each figure after the given transformation. Reflection across the y-axis. So reflection across the y-axis, the only thing you change is the x. The x becomes the opposite of whatever it was. So for p prime, instead of -3, -4, it would be +3, -4. And then we look in the answer choices, we see it here. And we don't see it in the other ones. So yeah, it would be A. If you want to verify, can for y, the opposite of -3 will be +3. And you see it here. And then for g, the opposite of 0 is still 0, so it'll be the same. So it's A. And 62, find the coordinates of the vertices of each figure after the given transformation. A translation of -4 is 0. So we're going to subtract 4 from the x value. So for r will be -4, -4. For y, -5, -3. For u, -1, 0. And for e, 0, -1. So the one that matches up for this one is B. Okay. Oh, 59. I missed 59. Okay. So we have square root of 15 over 4 square root of 10. So I'm going to factor those out. So 15 multiplies into 3 and 5. Sorry, there's no 4 on top. It's 4 on the bottom. And then 10 multiplies 2 and 5. So I will cross this out. I'm sorry. I don't know. I keep writing 4 on top. This is 3. Just just continue over here. I don't know, it's frozen. Okay, but we still need to rationalize the denominator. So we have to multiply by the square root of 2 on top and bottom. So now this turns into the square root of 6 over 4 times the square root of 4, which is 4 times 2, which is square root of 6 over 8. And that is all. That's the entire review. Any questions about finals next week? It's gonna be on Illuminate. So that morning I'll send you out the link so you could log in. The same as the quiz we took. And you have 2 hours to complete it. That's more than enough time because there's only 20 questions. And that should be it. All right. Between now and then, if any questions come up, don't hesitate to email me. Other than that, hope you have a good rest of your day. You're welcome. Welcome.